Alright, let's go ahead and talk about 7.1 on angles. So, as you can probably tell from the title of the section, we're going to talk about what angles are, we're going to illustrate an angle, and then we're going to learn about how to compare angles to each other. So before we can do all of this, let's go ahead and just define an angle. So, more or less formally, consider two rays AB and AC. So a ray is whenever I start at some initial point, and then I go off endlessly towards another point. So for example here, if I look at AB, this means I started at A, and then I go off in the direction of B. Notice that on A I have a point, and at B I have an arrow to indicate that I keep on going off in that direction. And then AC, again this means I start at A, and then I go off in the direction of C. And I'm actually going to go ahead and say let AB, this bottom ray, be our initial side. That is our starting line. And let's say I wanted to do a measurement of how far is the ray AB to the ray AC. In other words, what if I wanted this measurement here? So if I compare AB and AC, it kind of looks like I can just rotate AB and eventually end up at AC. Well, this ties into what we're going to call an angle. In particular, what I've drawn here, where I started at AB and started going counterclockwise to AC, we call this the positive angle. So that was the counterclockwise direction. But what if I wanted to go clockwise from AB? In other words, what if I wanted something like this right here? Well, that's what we call the negative angle. So it's important that we know this distinction between the positive angle and the negative angle, because this is going to be very important as we move on through the section. So again, positive means I start at AB and then I go counterclockwise. Negative means I go clockwise. So we have our idea of an angle. And now I want to talk about three types of angles that we're often going to talk about throughout the term. Again, let's say I have two rays, AB and AC, and let this symbol right here, I'm going to take a moment here, this is a theta, Theta. Let theta be the positive angle between the two rays. So, the first angle I want to talk about is this angle right here, when theta is equal to 90 degrees. This is what we call a right angle. This is basically like the corner of a room, if you have a normal box-shaped room. One thing I want to point out about this right angle is whenever we have a right angle, we often draw this sort of square in the corner to indicate that it is a right angle. So if you ever see a square in the corner, that tells me, or tells you, that we have a right angle 90 degrees. The second type of angle that we want to talk about is, what if I made this angle a little bit shorter? That is, what if my angle was between 0 to 90 degrees? Well, that's what we call an acute angle. And then I can also do it in the reverse direction. What if I wanted to make this a really wide angle, such as what I have here? In other words, what if my angle is between 90 to 180 degrees? This is what we call an obtuse angle. One thing I want y'all to notice also is that oftentimes we're going to talk about angles being between 0 to 180, at least in this context right here. We will be working with angles bigger than 180 or even smaller than less than 0 very soon actually. But these are the three types of angles for our introduction to angles. Now that we know how to classify the three common types of angles, let's go ahead and talk about angle pairs. How are two angles possibly related to each other? So, let's say theta 1 and theta 2 are two positive angles. So I have two angles, and if they add up to 90 degrees, in other words, if I drew them together and they formed a 90-degree angle, then we say that theta 1 and theta 2 are complementary angles. Or you might see some books say that they're complements of each other. So if they add up together to be 90, then we have complements. On the other hand, if these two angles add up to 180 degrees, then we say that they're supplementary angles, or they're supplements of each other. So these are two angle pairs that we often talk about as well. Now, let's go ahead and apply what we know so far. Example 1, solve for x. Using this diagram that I've provided for y'all, here I have part A. So in this diagram, to clarify and make sure that there's no confusion, this first angle from this bottom line, or bottom ray, to this middle ray is measured to be 3x degrees. So 3x is only from this bottom line to the middle line. And then from this middle line to this far left line, that angle is measured to be 2x. So what can I do with this diagram, and how can I even solve for x? Well, first off, I'm noticing that there is a square here, which tells me if I go from this bottom line all the way to this line on the far left, I have a full 90-degree angle. In other words, if I add up these two angles together, 3x and 2x, they should equal 90 degrees. So they're complementary to each other. So from here, we've done the setup, and now I gotta solve for x. Well, on the left, I have 3x and 2x. These are like terms, so I can pull them together to give me 5x is equal to 90. Alright, so now how do I get x by itself? Well, on the left, I have 5 times x. I want to get rid of this 5 somehow. So what's the opposite of times 5? I should be dividing by 5 on the left and the right. So on the left, the 5's cancel out, leaving me with x is equal to 90 over 5. I should get, 18. So I'm claiming here x is equal to 18 degrees. So we solved for x in this part A. Now let's move to part B. Very similar problem. So here I have 7x and 5x, and I want to solve for x once more. So again, to clarify, 7x is from this far right side to the middle line, and then 5x is this middle line to the far left line. So what I'm noticing here is that if I add these two angles together, then it looks like I end up with a flat line. That is, if I add these two angles together, I get 180 degrees. So that's exactly what I'm going to write here. If I take 7x plus 5x, I get 180. So I'm done with my setup. And now I'm going to solve it the exact same way as part A. On the left, 5x plus 7x, I get 12x. To get rid of the 12 times 12, I need to divide by 12, leaving me with x is equal to 15. And then we're done with this part B. We just solved for x. So for parts A and B, we explored what we know about complementary and supplementary angles. Alright, so now let's move on from here. The next thing I want to talk about is this thing called standard position. So what is standard position, and why do I even care about this? So let's go ahead and look at these two angles. And what if I wanted to ask y'all, which of these two angles are bigger? Are they the same angle that I just flipped around? Or what's happening here? So if you're looking at this, it's a little bit hard to compare because one, these angles are facing different directions, and I can't exactly pick these up right away and put them on top of each other. So one thing that we might want to do to compare and see if these are the same angle or if one's bigger than the other is, let's go ahead and start by rotating these so that they start at the same spot. In other words, I'm going to rotate both of them so that they look very similar to each other. So again, I can try to ask which one is bigger or if they're the same. You might be able to tell, but how can we know for sure outside of just eyeballing it? Well, if I go ahead and pull up my Cartesian plane, in other words, whenever I pull up my xy plane when I start graphing, what I can do with both of these angles is I can move them such that they start at the origin. In other words, I can move my first angle over like this, and then I can also do the same thing with my second angle. I can take it and move it over. Looking at this, well, now it's very obvious. My second one, the blue angle, was the larger angle. So the way I've drawn my angles here is actually what we call standard position, where I start at the origin, the middle, and I also start at the x-axis. So it's really nice for us to look at the standard position because, well, it gives us a very quick way to compare two different angles, or more than one angle. If I want to be a little bit formal here, an angle theta is in standard position if its initial side, so its starting line, lies along the positive x-axis. And just as a reminder, the x-axis, that's this positive line right here. So that's saying if I want to always start all of my angles along this line here. So this is what we call standard position. And we're actually going to be using the standard position for pretty much the entire term. Again, this gives us a nice way to compare two different angles. So now that we're familiar with standard position, let's go ahead and move into our next example. I want you to roughly illustrate the following angles in standard position. In other words, I want you to take all of these angles, and I want you to start on the positive x-axis, that is along this line on the right. So for part A, I have 134 degrees. So we're going to be roughly illustrating this. I'm not necessarily expecting you to have it perfectly down to the exact measurement, but we should be in this about the same ballpark as the correct answer. So for part A, to help me illustrate this, I'm going to go ahead and actually label some lines here. So since I start along this positive x-axis, we're going to say that we start at 0 degrees. And then if I move up to this top line up here, we can tell that this is a 90-degree angle, then 180, 270, and then 360. So notice also that I'm moving in the positive angle, that is the counterclockwise direction. So for 134 degrees, I'm going to go ahead and start on this side. And I did this a little prematurely here. Oops. Let me take that back. So 134, that's obviously bigger than 90. So I'm going to move 90 degrees. 134, that's definitely smaller than 180. So I'm expecting 134 to be somewhere in this top left square. But how far do I go exactly? Well, I've already gone 90 degrees. If I go subtract 90 from there, this tells me I need to go 44 more degrees. So if I go another 44 degrees, I'm roughly somewhere around here. This should give me 134 degrees. Again, I'm not looking for an exact answer or necessarily an exact drawing, but we should be in this correct ballpark. So this is what 134 degrees looks like. So we have part A complete. Now let's go ahead and deal with a much bigger number. Let's say I want part B, 416 degrees. How might I illustrate that? So I'm going to clear my screen. As per usual, I'm going to start in standard position. So the first thing I'm noticing is that it's definitely bigger. 416 is bigger than 90. It's bigger than 180. It's bigger than 270. It's bigger than 360. So if I want to look at an angle 416, since I'm bigger than 360, I know that I'm already going to be moving in one full circle already. That is, I'm going to do one full rotation. So this is one rotation. How much further do I need to go? Since I've already moved 360 degrees, I'm going to go ahead and subtract 360. So 416 minus 360, that leaves us with 56 degrees remaining. So now I need to plot 56. Well, 56, that's definitely between 0 and 90. So I know I'm going to end up somewhere in this top right corner, roughly around here. So this is what 416 degrees is going to look like. So again, I noticed I went a full 360 degrees and then 56 more degrees to give me 416. Alright, so I had part A and then I have part B. Now let's deal with a big number that's also a negative angle. So remember, for parts A and B, I was going counterclockwise because they were positive angles. But remember what I said earlier in the lecture. If we're dealing with a negative angle, then I'm going to be going in the clockwise direction. So let's go ahead and work with that. So for negative 900, to help me with this, I can't exactly use positive 90, positive 180, positive 270, positive 360 to help me because I'm dealing with a negative angle. But what I can do is, since I know that I'm working with a negative angle and I'm going clockwise, that is in this direction that my mouse is moving, I'm going to go ahead and label these four sides again. So I have 0 degrees. If I go clockwise and stop here, that's negative 90 degrees. Then negative 180, negative 270, and then negative 360. So I'm going to follow the same intuition as 416 for negative 900. So negative 900, I think we can agree that's definitely going to be going further than negative 360. In other words, I'm going to be doing one full rotation around, and that animation was supposed to start on the left. But regardless, this is one rotation in the negative direction. So I've already gone negative 360 degrees. How much further do I need to go? Well, to figure that out, I'm going to go ahead and say negative 900 plus 360 that's already accounted for. I need to go negative 540 more degrees. Well, you're probably noticing again, negative 540, that should give me another full rotation. So I'm going to go around my origin once more. I'm going to go another rotation. That's another 360. So since I went around another 360 in the negative direction, let's add 360. And now my next angle is negative 180. So from my point here, I need to go 180 degrees in the clockwise direction. So I have 90 degrees and then negative 180. Then thus finishing my angle for negative 900. So the big takeaway from this, long story short, positive angle, we go counterclockwise. Negative angles, we go clockwise. And then if it's a large number, we may have to go around multiple times. So this is example 2. Let's move on from here. So the next angle groups that I want to talk about are what we call the quadrantal angles. So an angle theta, if I have an angle that's in standard position, it's a quadrantal angle if I am 0, 90 degrees, 270 degrees, 360 degrees, or any equivalent angles. So there is a reason why in these previous examples, let me go back 2 slides, that I labeled my 4 sides like so, where I had 0, 90, 180, 270, 360. We use these quadrantal angles as sort of a guide to help us map out our angles that aren't so clean here. Because we're familiar with what a 90-degree angle is, what a 180-degree angle is, and a 360-degree angle would look like. So we use these as sort of guidelines to help us through. And notice in that previous definition I showed earlier, there was also etc. So etc. to include, these are also quadrantal angles, negative 90, negative 180, negative 270, negative 360, because they still can serve as guidelines for us as we go through and try to map out our angles. So we have our quadrantal angles. Let me go back to that slide. So now that we're familiar with quadrantal angles, what else can we look at from here? Well, if I want to do another comparison of two angles, theta 1 and theta 2, they terminate or they end at the same spot. If that occurs, then we say that they are coterminal angles. So for example, here I have some random angle that I've just drawn out. It's somewhere between 0 and 90 degrees based on how I've drawn it. But consider this. What if I was already standing here in this and facing this direction? What would happen if I rotate it 360 degrees? Well, if I rotate it 360 degrees, then I end up at the same spot, right? Again, if I'm facing one direction, I turn around 360, I'm still facing the same direction. We call these coterminal angles. Or in other words, they're equivalent to each other. You're still facing the same direction. Even though for one you may have done a few more spins, but in the long run, you're still facing the same direction. So we have coterminal angles. So again, you notice that I'm using the word equivalent because throughout this course, we're going to be treating them as essentially equivalent angles. They're going to have the same properties in the long run. So we have coterminal angles. This also tells us that if theta 1 and theta 2 are coterminal, then they differ by a multiple of 360. So if I use this example that I had here, I could turn around a whole 360 again, and then I still have a coterminal angle, and I can do it as many times as I want. So let's move from here. What else do we have? Example 3. Find the angle of least positive measure that is coterminal with the provided angle. So if I have a really large angle that's bigger than 360, perhaps it would be nicer if I can find an angle that's pretty much the same thing, but something that we're more familiar with between 0 and 360. Typically, it's a lot easier for us to imagine, all right, what's the angle between 0 and 360, rather than, for example, in part A, what is 908 degrees. So the good news for this is that we can actually do this fairly quickly. Remember in that previous slide I said coterminal angles differ by a factor of 360. So in other words, if I keep on adding or subtracting 360, then I still have a coterminal angle. But I want the angle of least positive measure. In other words, the angle between 0 and 360. So for part A, we're going to go ahead and just subtract 360. If I subtract 360, that is, if I turned around 360 degrees, I'm still facing the same direction, so I haven't caused any problems yet. So if I subtract 360, I get 548. That's still not between 0 and 360, so let's go ahead and subtract 360 again. If I subtract it again, I end up with 188 degrees. Well, 188 degrees, is that a positive angle? Definitely. Is it between 0 and 360? For sure. So I found my least positive angle that is also coterminal. What about for part B now? What if I have a negative angle? Well, I definitely don't want to be subtracting 360. If I did negative 75 minus 360, I'm just going to get a larger negative number. So instead of subtracting 360, I'm going to go ahead and add 360. And this is still fine. This just means I turned around and rotate it in the opposite direction, but I still end up facing the same direction. So if I add 360, negative 75 plus 360, I get 285 degrees. Is that a positive angle or a positive number? Yes. Is it between 0 and 360? For sure. So I have my final answer. Now go ahead and try out part C for a moment here. I would suggest that you pause the video here and see if you can get the answer for part C. And now hopefully you've gone ahead and paused the video and you didn't just wait for me to continue talking, but regardless, we'll continue from here. Again, I have a negative number. I definitely don't want to subtract 360. That's never going to give me a positive number if I keep on subtracting more. So I'm going to add 360. If I add 360 once, I get negative 440. I'm still negative, So I'm going to add 360 again, giving me negative 80. Still not positive. Let's add 360 again. Add 360. I finally have a positive number, positive 280. Is positive 280 between 0 and 360? Yes. So I have my final answer for part C. So depending on the angle, we're going to add or subtract 360 until we get between 0 and 360. So that finishes our example 3. Now, oh, actually, there is no now. That's the end of our slide. All right, so that's all for this section. I'll see you for the next one.